Welcome back. We are finally to our last rule of factoring, polynomial expressions. And our last rule's name is called the sum or difference of perfect cubes. So again, before I can teach you how to use the rule, I have to explain to you the vocabulary. Every word in that name is a description of what you're looking for in your expression. So, sum means addition, difference means subtraction. So to do this rule, sum or difference of perfect cubes, you need an addition sign with two terms, one in front and one behind, or you could have a subtraction sign with a term in front and a term behind. So to use this rule, you need two terms, a binomial, and they can be connected either by addition or by subtraction. Okay, so that's cool. The next word is perfect cube. So that's directly related to a perfect square. A perfect square was a number times itself. You multiplied that number twice. Cubing means to do it 3 times. So a perfect cube is a term you multiply to itself 3 times. So again, there are numbers that are perfect cubes, and there are variables that are perfect cubes. And we got to be able to distinguish that. So let's look at numbers. Let's go off basic arithmetic. We're going to take numbers and multiply them to themselves 3 times. So here we go. What's 1 times 1 times 1? Well, that's 1. So 1 is a perfect cube. What is 2 times 2 times 2? Well, 2 times 2 is 4. 4 times another 2 is 8. So 8 is a perfect cube. What's 3 times 3 times 3? 3 times 3 is 9. 9 times another 3 is 27. So 27 is a perfect cube. One more. What's 4 times 4 times 4? 4 times 4 is 16. 16 times 4 is 64. So 64 is a perfect cube. So in your notes, I have the list of the first 10 perfect cubes. Again, it would make sense to commit this to memory. You should be able to rattle off the perfect cube list. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1,000. And then I have a dot, 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 because that list will never end. But normally in an algebra math class, we limit ourselves to the first 10. Now we need to talk about variables that are perfect cubes. Again, a perfect cube means you multiplied that same expression 3 times. So let's go. What's x times x times x? Well, that'd be x cubed. What's x squared times x squared times x squared? Well, we know when we multiply variables, we add our exponents. So 2, 2, and 2 would add to 6. What's x cubed times x cubed times x cubed? I'd add my exponents 3, 3, 3, and I would get 9. So if you look on your PowerPoint, I have the perfect cube variables listed. X cubed, x to the 6th, x to the 9th, x to the 12th, x to the 15th. Now let's look for a pattern. Are all those exponents even? No. The 6 and 12 are even. Are all the exponents odd? No. The 3, the 9, and the 15 are odd. So we got to come up with a rule. What do you notice about all those exponents? 3, 6, 9, 12, 15. Hey, those are all your 3 times tables. So those are numbers that are multiples of 3. So any variable that has an exponent that's a multiple of 3 would be a perfect cube. So what would come after x to the 15th? Well, that would be x to the 18th, because 18 is a multiple of 3. And then it would be x to the 21st and x to the 24th. So, to use our new rule, our last new rule, the sum or difference of perfect cubes, your expression has to have several things going on. It's got to be a binomial that has either addition sign in it or a binomial with a subtraction sign. Every number in that expression has to be a perfect cube. Every variable in that expression, the exponent must be a multiple of 3. So if you look in your notes, I have 3 expressions, and I want to know which one represents either the sum or difference of perfect cubes. So let's look at x minus 27. Well, it's got the minus, it's a difference. 27 is on the perfect cube list. It's 3 times 3 times 3. But look at x. What's understood to be its exponent? 1. 1 is not a multiple of 3. When you say the 3 times tables, you don't say 1. You say 3, 6, 9, 12. So that's off. Look at the next expression. X cubed plus 3. Well, it has a plus, which is okay. We can have a sum. X cubed, now your exponent is a 3. It's a multiple of 3. But look at your constant, 3. Is 3 a perfect cube? Can you multiply the same number 3 times to make a 3? No, you cannot. If you look at your perfect cube list, 1, 8, 27, 64, 125, you never say the number 3. So cross that expression off. What about my last expression? X cubed plus 64. Well, it's got a sum, so we're okay. X cubed has an exponent of 3, which is a multiple of 3, good. 64 is on the perfect cube list. It's 4 times 4 times 4. So that last expression, x cubed plus 64, is what we're going to learn how to factor in our next video. See you then.